Okay, good morning everyone. So today's agenda I'm thinking of is cover a few small miscellaneous topics that give you the ability to one, work with formatted reports, working with DML statements that you sort of already know, but a review will be helpful since you're going to end up using it in assignment 8. And then going over the concept of transaction, and then talk about how to create tables so you can start your work on Lab 7. In fact, the most important topic for today is creating tables and preparing for working on assignment 7. So as you already know, assignment 7 is based on 6. You've created a database schema and you're going to take that DB schema and you're going to end up taking that DB schema for creating tables in assignment 7. So essentially your entire database will be created. So let's get on with the topic quickly. I'll be grading your assignment 6 this week and getting back to you. So you have it for your assignment 7. So assignment 6 will be graded this week by probably Thursday or so. And then, so talking about how formatting works to create readable reports. So there are a few topics in this that have to be discussed. So first thing is if you have to take input for SQL scripts, how do you do that? And then a few things on customizing the SQL environment for output and producing a little more readable output so the columns and rows and page size, those kind of things can be set up. And then finally, we're going to talk about creating script files, which is something that you're going to need for Lab 6, Lab 7, and Lab 8. So to create an interactive report, you can use SQL substitution variables, which are basically created using a single ampersand or a double ampersand. We can also use the define and accept command. So the idea is that if we create variables with define and accept, with define, we can pass those between different SQL statements. So you can actually write some more stateful programs with multiple SQL statements. And you can also, of course, create nice headers and footers. So this slide shows you how we can use a single ampersand variable and to prompt the user for an employee number. So we basically say where emp number equals ampersand employee num, and guess what happens? It gives us a prompt for the actual variable name. So the value is taken, and then the SQL statement is compiled, and the results are produced. We can also set verify on. This is a command you'll probably end up using in SQL statements, in SQL scripts as well. And the idea is that what it does is it will, when you set verify on, and if you're using substitution variables, it's going to print the value before and after. So, here we look at old and new values, as you can see in the bottom part of the screen, where we say enter value, and then it shows the old value and the newer value. That's the idea of the verification. If you are working with char data type or date data type, we'll end up putting the n% in single quotes. So if you are taking a name value or like a name or date, you simply put the n% in single quotes, as you see in this slide. We can use column names. I mean, we can use substitution variables like using n% for a lot of these things. Like if you want to add a where condition, or we want to dynamically change order by, or add column expressions or table names, or maybe even a subquery like an entire select statement can be put into a string. So this is how we use it for column name expressions and text in runtime. So if we want to select a column name and specify a condition on the fly, or do a order by on a column, we can put an n% in front of these in our SQL statement, and you start seeing this. You start seeing these results. So now we have double n% substitution variables. If you want to reuse the variable value without prompting to the user to enter it each time, right? So then we can use the double n% the first time around, and then a single n% the second time around. So here column name department number is used twice. And then we have variables that you can define explicitly using the define command. So you can specify a data type, and when you use %, double %, or the define command, these are all called SQL plus variables. These are all called SQL plus variables. So we use the define command to create a variable, and accept command to provide a prompt to a user so they can enter a command or a message to enter to show to the user, like enter value for something like that. Can we have the default value displayed? There is a show command, Munaf, that you can use for that purpose. So the accept command would look something like this. It will say accept department from accept department prompt, and prompt you just type a message name, and then to go off and declare your actual variable name, you'll just use the n%. So Okay, so variable, if you want to define or undefine, we can use that, and this can be particularly useful in our SQL Plus environment. We can go in our script called login.sql. You can actually go in and predefine those variables. So these are all then would be created at startup. I don't think you guys are allowed to modify login.sql, but one day if you have your own database installed, you certainly will be able to do this. Shared environments, I don't know if we allow this or not. Anyway, here is how you use define. This is like declaring a variable in a programming language. So we say define variable name, and then we can provide a default value. So, and then when you use the define command, again, like define department name, for example, it will show you the default value. This was what Manaf you were asking earlier. So using just the define command will prompt the will show you the value, and then you can go ahead and use that with an %, in order to prompt the user for a value if you so choose. There's also a set command and a show command. Set command allows you to control the current session properties, and so you can say set system variable name. If you type help set in SQL Plus, you will see all the properties that you can set. So set echo on, set echo off, is setting echo on and off will basically print the command that you are entering. So if you end up using a lot of substitution variables, the set echo on will actually print the entire SQL statement as it's compiled with the resulting values. And then there is a show command that basically will show you the properties of the session variables. If you end up like saying show echo, it will go ahead and show that property. So these are all the properties that you can set, and this is particularly interesting for you guys because you can control the size of the page using page size, for example. If you want a wider line because you have lots of data to show, then you can alter the line size from 80 to maybe 120. If you want to turn on pause after each statement, so after each page, forgive me, then you can turn pause on and off, so the user has to hit the space key or something to go from one page to the next. You can turn on headers, etc. So these are few of the important ones, and there's a lot more that exist out there that you can use. All these customizations can be saved in SQL Plus. I'm sorry, using the login.sql, and here are some of those commands that you can set in. Here are some of the SQL Plus format commands that you can use to set the title, column, setting break on or off, those kinds of things. So here's usage of column. If I want to provide a specific format for the values to be displayed, you probably remember the format command from the chapter of functions, where we had a formatting specifier for numbers and characters. That can be used here for formatting. You can also provide a header text and do left or right alignment or center alignment as you see fit. Here are some examples of usage of column command, because again, I think for formatting the data, you'll probably end up using it. The first one shows a larger string size, showing employee name using 15 spaces. The second one shows salary using 5 numbers, hopefully just the monthly salary. And then the if the value of the manager column is null, it shows as no manager. So when you want to look at the column settings, you can just say column ename and it will display the column settings. If you want to clear the column settings, then you can say column name ename clear, and that will clear all the settings for you. When it comes to formatting, like I said earlier, it is similar to the property set that we learned about in the chapter of functions. So when you're displaying a number or a currency value and so on, these are the ways to do it. Break command will suppress duplicate and section rows. So if you want to just suppress duplicates, you can say break on ename on job. So that will suppress the duplicates on the ename column. And if you want to, section out certain rows, then we can use the next command using the skip subcommand. Again, a lot of useful things that you should try out. If you want to set up a report header, a report footer, you've got the T title and B title commands available. And if you want to create a SQL script like I showed you for lab 1, you can do so. You can basically name the script.sql, and on top of the script, again, this is something you might want to take notes on because I don't plan on posting it. So you can say something like this, like spool and then file name .txt. We can say set echo on, and then we can also probably say set verify on at the start. And then we can have our SQL statements, whether these are insert statements, create statements, or whatever. And then in the end, what we want to do is say spool off. What spool and spool off does is it actually writes the output of the set of SQL statements in a text file, so you can go back and review what happened. If there's an error that needs to be fixed, then you can see that error and fix things. So spool off will turn off the writing, and you should also at this point say set echo off and set verify off. So and then you can take this entire script and give it a name like lab7.sql, and using WinSCP, you can copy it to your SQL account and then run it on the server side. The only thing you want to be very careful about with Lab 7 is you want to set it up like I did with Lab 1. Whatever tables you create in a SQL statement, consider dropping those first. So let me show you what I'm talking about. So you see this when I gave you guys run this following script, and you see how I drop the tables first, and then I go in and create each table, right? So that way, if you end up doing that each time, the fun part of it is that you will be able to use your script to reset the database. So in case you guys have issues with labs 1 through 5, the only thing we had to do was drop the table and then, basically run the script which drops the table and then recreates it. And not only that, it adds data. So, you're not adding data in lab 7, you're adding data in lab 8. So please be careful about that so as to not write the insert, update, and delete statements just yet in lab 7. We do that separately in lab 8. Okay. So back to the topic. The next thing is DML statement. How to write insert, update, and delete statements. So this topic is also a small one. We're going to look at when you add a new row, modify an existing row, or delete a row. So adding a new row like department 50 into the department table, right? How does that work? We use the insert statement. So we have insert into table a set of column values, a set of column names, and values associated with each. So we must, excuse me, we must provide with each column name, we must provide a value for it. And we can only insert one row at a time, like you see here. So if I provide, this is all optional, column names are optional. If I don't provide column names, I must provide values in the order they show in the describe. That's the default order. That's how I find out the default order of the columns. So, and if I'm using character or date data type, then I include it in single quotes. So, okay. I can also insert new rows with null values. So you can see the two approaches where I define the column names and other where I don't. I think for these slide decks, you just want to try out some of these commands. So you can be good with it for usage for Lab 8. This thing will be used in Lab 8 probably the most. We can insert special values, so we can have like, things like sysdate, which will give me today's date. If in fact the insert is done on the day the person is hired. Adding a new employee into the employee table. In the first case, I'm only providing a set of values in the default order. And then once the value is inserted, you can always go back and do a select to see what in fact was inserted. Okay. We can insert values using ampersand. So, you can have the user enter specific values using the ampersand operator, which prompts the user to enter a value. So a lot of this stuff is kind of very simple. You can use the except command like I've shown you in the last slide deck to create, to declare variables with using the define command, and using the except with prompt to print custom messages. I will not belabor that point right now. I'll simply move on to the to the next topic. We can do insert as select. That does a copy of one table into another. So the only thing is that we have to match the number of columns in the insert statement along with what we are providing in the select statement. So when we say insert into managers and we provide all the column names, we must provide the select statement with the same idea. So employee number corresponds to ID, e-name corresponds to name, to salary, and hire date to hire date. Updating the data in a table requires usage of the update statement. The update statement will modify existing rows, and you can modify more than one value at a time. You can also modify more than one row at a time if required using the where clause. It all depends on the condition. In this statement, we are going to only update the department number of the employee 7782. If we were to set the department number to 20 for all employees, then we'll not have a where clause. That will update the entire table to department number 20, which might be a mistake because, especially if you have more than one department. We can also do update with a subquery or update as select. So this would be correlated query. So we are selecting job number and department number for employee number 7499 and setting it for 7698 because the two individuals probably work in the same department and have the same job. So using subqueries to write update statements is pretty common. This is again, correlated queries that you're familiar with from Lab 4. You can get integrity violation constraints. Why would you get these? If you try and insert a value that does not exist in the parent table, so that would cause a referential integrity violation. Again, another concept that we have clarified twice, one at the beginning of the course and second when we talked about Lab 6. Removing a row is deleting a row, which happens with the delete statement. You'll probably notice that the syntax when represented with rectangular brackets tends to be that syntax tends to be optional. So if we say delete table, that will delete the entire table. If I say delete from table where condition, then I'm controlling certain number of rows that will be deleted with the where clause. Deleting the entire table will just get rid of the data from that table. The table itself, however, is not deleted. You still have to drop the table separately if you want to do so. But deleting just deletes the table from the database. We can use subqueries to use correlation. Like in this case, we are saying let's delete all the employees in sales. So we select the department number based on the department name and then delete that. Delete the employees in that. So deleting a row that has a primary key referential integrity violation will occur, and it will show itself this way. So what I'm going to do is avoid the discussion of transactions today. We'll probably cover it next time. What I want to do is I wanted to give you the basic DML operations, and then I wanted to send you off to working with create table, so you can do you guys can do work on lab 6. So we'll talk about creating our database schema using create table statements, which is our next topic. Everyone can hear me okay, right? Any questions from anyone so far? Just want to verify you guys can hear me, since we are online and can't kind of see each other, so you know. Okay, so creating database tables. I call this creating things in database, because you can do more than one thing. So we're going to learn how to create database objects here. These are the different types of database objects you can create: table, view, sequence, index, and synonym. Table is the entity that has rows and columns. View also has rows and columns that is based on view also has rows and columns, but the view is based on the tables using a select statement. Sequence is generally an object created to generate unique values incremented by 1. You'll end up using this in lab 7. Creating indexes is for improving the query performance. What is an index? If you look in the back of your textbook, there's usually an index in the back that is sorted, that has a list of topics associated with a page number. A database table index is the same thing. You take the value that you're trying to do a search on, like in the where clause, and we associate that to a row ID. So let's say if you're looking for employees in department 30 and there are 4 employees, the index will give you the 4 row IDs associated with that query. Very similar to the index lookup in the back of the book. Synonym is an alias, an alternative name given to an object because you're either trying to hide the real object name, or maybe the object name is too long and you want to just have a shorter version. So that would be where we would use a synonym. There are these naming conventions that are used for creating a table. The name of a table or any object must start with a letter and cannot be more than 30 characters long. You can use those characters that are specified in the third bullet: lowercase a through z, uppercase a through z, 0 through 9, underscore, dollar, and the hashtag. We cannot have duplicate variable names in the same scope, and we also cannot use reserved words like table or index or create or update or delete as object names. These naming conventions have to be followed, otherwise you'll get a syntax error. The create table clause is, you need to have the create table privilege, which when your accounts were created, you have that privilege given to you. So you specify table name, column names, data type, and size. That's the most basic thing you have to do for creating a table. Tables that belong to other users are generally in a different schema. If you have permissions to look at other individuals' database objects, then you can use the username dot object name to either view the data or insert data or so on. So this is how the create table works. We write the create table statement, we provide the table name. We then write all the column names and their respective data types with the size that is used for each column. Once you type the create table statement and hit enter, it will respond with a positive or with a positive message like table created or with a syntax error. Then we say describe table, and then the describe table command will show all the column names and the constraints that may have been added on the tables. We'll talk about constraints in a little bit as a separate part of this chapter because it's very important. We have user tables and we have data dictionary. User tables are the ones that you create. So all the tables that we created like employee and department and salary and so on are part of user tables. But you also have what is called a data dictionary, which is a collection of tables that are created and maintained by the Oracle server as information on database objects. We often query these data. We often query the data dictionary to figure out what may be going on with the properties of some of the tables. Here are some examples of the data dictionary, looking at user tables, user objects, and user catalog. Depending on what you're interested in, you can find information about tables owned by a user or objects owned by a user or um, table views and synonyms in user catalog. These are all the data types that are supported in SQL. We have varchar, to, char, number, and date. Those are the 4 common types you'll end up using in Lab 7. The other 5 data types, long, clob, long, raw, blob, and bfile, those are generally they're covered in PLSQL. So we'll cover those at that point in time. Varchar 2 is a variable length character data, which basically means that variable length character data. So if I declare a size of 50 and then I have size of if I say size of, and I only put like sing in it, which is 5 letters, then we'll end up using 5 spaces. When the data type column is char, when the data type column is char, if I have 50 characters in size and I specify my last name Singh, I will only end up using I'll end up using all 50. So we'll have 45 trailing spaces in that name. That's the difference between variable length string and fixed length string. The number data type can be specified with length and precision. So please be careful with this, with the specification, or not to make numbers too large or too small, because that impacts the database size. Tables can also be used using subquery. So we call that CTAS, or create table as select. So when we say create table as select, we have something like this. So we say create table department as select from and we say employee number, name, annual salary, and hire date from EMP where department equals 30. When we run this query, we are going to inherit the properties of all of these columns from the employee table and make those of the department table. We're also going to take the data that is associated with the department number 30 and insert that into the department table. So create table as select is essentially a very powerful query because not only it's creating a new table, it's also taking the data and inserting it all at the same time. This is what we call a fourth generation language, where you write one line of code and you can accomplish a whole lot with that one statement. In addition to create table statement, we have alter table. You can write an alter statement. So alter statement can alter the table in many ways. You can add a new column or modify an existing column. So if I were to add a new column in a table, I can say add column, data type, and a default value. And if I were to modify a column, I can modify the existing using this. So and then alter table and create table basically work in tandem. This is how adding a column would work. Alter table, department, add a column. So a lot of times people go through a create table statement, but then you obviously don't end up dropping the table. You don't end up dropping the table, you end up modifying the table, right? Or if you don't like the size of an existing column and you want to change it from 10 to 15, right? You can just make that change by using the modify column clause. You can of course add comments. That's usually a good idea for like from a coding standards perspective. So you can add comments on a table or a column using the comment clause, and all of these comments are at the end of the day saved in those data dictionaries listed in this table. It's a good practice, but do people actually do it is another question. This is an important part of working on Lab 7. You guys will need to add a set of constraints that you have declared either as primary key or foreign key or not now. And the goal of this part of the chapter is to essentially show you the syntax so you can work on it. Once you have done the create table statement, meaning you have defined all the column names, column data types, and so on, then in the end of the create table statement, you generally can provide the set of constraints. Sometimes people prefer to just use a create table clause for specifying the columns, for specifying the column information, and that's the end of it. And then they use the alter table statement to modify the table. So you can bring in constraint definitions at a later time using the alter clause. How you want to do it, if you want to do it in one create statement or a different alter statement, is totally up to you. So valid constraint types are these 5, and we'll look at each one of them. Generally, there are naming guidelines for the constraints. Constraints that are created by where we don't give a name, like not null. The constraint name is defined by the database using this naming convention, sys underscore c and then n, where n is a value that just gets updated each time. So it's kind of a very generic name. If you end up defining a constraint name at the time the table is created or altered, you'll generally end up naming the constraint yourself, and we end up using table names or column names to do that. So something like this. So constraints can be either defined at column level or table level. When a column level constraint is defined, it's defined before the comma. When a table level constraint is defined, it's defined after creating all the columns and prefixed with the word constraint. So we say constraint, and then here we end up specifying the constraint name, and this is the naming convention that I like to use. Table name, column name, and the constraint type that you have, whether it's a primary key, foreign key, etc. When we define a primary key constraint, we are required to use the primary key keywords, and then we specify the column. We specify the column name, that is the primary key column. It is possible that you can have more than one column as a primary key. So I can say employee number, comma, employee name or ename, and so I can have employee number, comma, ename as the constraint name, if you will, as the set of primary keys, excuse me, in the primary key definition. Everyone can still hear me okay? Just to double check, please. And I'll keep moving here. We have, when we define the constraints, we can either define those at column level or table level. So not null constraint is always defined at the column level. So that basically will make the values not null. That'll make the values not null. So. And then we've also seen the unique key. Here, unique key is being defined at table level. Although it can be defined at both table or column level, all we are trying to do is we can give the column name a unique value. I mean, a column value can essentially be a unique value. The unique constraints can be null. Column values that are unique can be defined as null. So can basically have a not null constraint and then still define the value to be unique. So primary key is defined at table or column level, but again, when we use the constraint keyword, that refers to the table level constraint. So this is how we create the primary key constraint. We've got the constraint name, primary key keyword, and then the column name. So then we have the foreign key also defined at table level, and we've got constraint name, foreign key, department number, and then we must use what does that foreign key refer to in what table. This is what, folks, is what enables referential integrity. So department number in department table becomes the foreign key to the department table. Excuse me, department number in employee table becomes a foreign key to department number column in the department table. Then we have the check constraint, which is basically a simple rule that allows us to satisfy the any criteria for when we are doing insert, updates, or deletes. So if I end up imposing a check constraint, then when I do an insert, say on the department number column, if I insert 100, then so department number between 10 and 99. So if I end up inserting a value like 100, the check constraint will do a check and disallow the insert or the update. So we can add a constraint or drop a constraint. So we can use the alter table command to add a constraint. So we say alter table name, add constraint, and then the constraint definition. Similarly, if you wanted to drop a constraint, we'll use the alter table command to do so. This will remove the foreign key constraint on the employee table. If I want to remove the primary key constraint, I can often use the cascade command. That command will eliminate all the related foreign key constraints that were created on the primary key. So this is going to require a little bit of practice from your end as you begin to get Lab 7 together. There are times when if I'm trying to do bulk uploads and I want the loads to be faster, I can simply disable a constraint. So we're not doing like checks on the referential integrity or check constraints or unique constraints. We can simply go in and say alter table name, disable a constraint. When a constraint is disabled, basically you end up inserting all the values. But if any of the constraint rules are broken, when you go back to enable the constraint, and if we turn on the check option, then it will validate the entire data and make sure that the rules of the constraint are not broken. But um, sometimes for data loads, these sometimes for data loads these constraints are disabled, and so we have to be somewhat careful in using that. Cascaded constraints is a way to basically drop constraints that refer to each other. This specifically applies to primary key and foreign key. A lot of times one primary key may have many foreign keys as dependencies to it, and if you end up deciding dropping the primary key constraint, you don't have to go in and check which columns are the foreign key columns. You can just use the cascade option and system will automatically figure out which columns are foreign keys and drop those columns. And that's basically what I just said, that the cascade constraint clause drops all multi-column constraint defined on dropped columns. Constraints generally, when enabled, are one constraint at a time. We don't enable disable using cascade. There's a user constraints. I hope, Mustafa, that answers your question. If not, please let me know. We also have the ability to view constraints using, we have the user constraints dictionary. So all the constraints that are created for user tables are in that data dictionary. So you can view the constraint type, the constraint values, formulas, if it's enabled, disabled, etc. The only thing you have to be careful with is if we're using system-defined names, and it's kind of hard to associate, if there's a constraint name like with 674 value or 675 with the sys in front of it, who knows what table it's associated with. So in that case, we can use another dictionary called user con columns, where we can take the constraint name and see what column it might be associated with. And that's basically a little bit of probing or queries you have to do to figure out what column is associated with what constraint. Information is all there in the data dictionary. You just have to go look for it. And hopefully these data dictionary views give you an idea of where to look for that information. So for lab 7, you don't have to build a data space. You don't have to build a table space because one is already created for you. And you also don't have to, you have to work with partitioned objects. But I want to cover the more basic things first before I cover these topics. So what I'm going to do is jump ahead, if I may, to part of storage management, where we can look at creating sequences and synonyms. Those are two topics that are, I guess, important for you all to do lab 7. So we need to talk about sequences. So so far we have talked about creating a table in different ways. We've talked about columns that can be associated with create table and how to create constraints with the create table class. So now if we can focus on sequences, you need to use sequences in your lab 7 and 8 and synonyms because that gives us the ability to create aliases. You're not required to use those, but it's good to know those. And then what we'll do next time is talk about creating table spaces, partitioned object, and also look into storage management. So when in fact a table is created, we can see how it's stored in the database. So sequences serve a purpose of automatically generating unique values for primary keys. And it builds up efficiency because you can step ahead in generation of these automatic primary key values for inserting in a database. This is how a sequence is created. Generally, you just have to say create sequence, sequence name, and that's the end of it. All the other elements are optional. You can increment a sequence by 1 or 2. 1 is the default value, but you can increment it by 5 or 10 if you want. You start with n. If you don't want to start with 0, you want to start with 100, then specify that. You can specify a min value or max value. Whatever is underlined are default values. And if you don't want your department numbers going above 200, then specify a max value of 200. Cycle and no cycle is resetting. So if I go from, if my max value is 10 and min is 1, I'm going to go from 1 to 10 and reset back the sequence back to 1 if cycle is turned on. If no cycle is turned on, then it won't generate any more new values and throw an error at the time of the sequence usage. Cache, the idea is to advance maybe certain number of additions at a time. So if I say cache 5, then it will like have 5 values ready to be used ahead of time, because at the time of insert we are trying to save every little processing time we can, and by generating ahead we avoid that and we improve the performance. Here is an example of the department number sequence that starts with 91, increments by 1 with a max value of 100, showing a total of 10 departments. It has no cache and no cycle. So now the question is, you can create a sequence, but how do you check information on it? And how do you actually use it? So I can go into the table name user sequences in the data dictionary and find all the properties associated with the sequence to see what each one looks like. And then I also, to figure out the usage of the sequence in a database table, I can use nextval and curval to see the current value of where the sequence is at, and if I say nextval, that usually adds a value to the curval and returns it. This is how you'll use the insert statement. This is how you'll use a sequence and an insert statement. Sorry, that last comment didn't make sense. So I'll say department underscore department number dot nextval, and we end up inserting a new department. If I want to see the current value, then I can just say select sequence name dot curval from dual. Dual acts like a temporary table. So it takes the current value and adds a row into a temporary table called dual, and we basically select from that. See, we can't say show or something like that because such commands are not available. That's why the dual table ends up getting used for some of these kinds of things. Modifying a sequence is just an alter sequence statement. So we say alter sequence, and there you see all the potential changes you can make. Here are some things you have to keep in mind about using a sequence. So you obviously have faster access to memory. We can have gaps in case insert, update, or something fails. But we can use the alter command to fix those if required. Altering a sequence allows us to change its properties, whether it's the increment value, max value, min value, cycle option, or cache option. You can use the alter command to do that. And dropping a sequence will get rid of it essentially. It does not affect the prior values that were inserted using the sequence, but it just drops the object itself. Synonym is creating an alias for an object. So here you can see create synonym name for object. So something like this. So if I have a long table name, I can shorten it. And then when I create a synonym, I can use that in any table inside my schema. This should get you ready for Lab 7. Let me talk a little bit about Lab 7 before we go today. And the video lecture will be posted later this evening, so you guys can, access it. So in assignment 7, you have to, I think you can work on question number 1. It says, based on schema in Lab 6, create tables with constraint. So whatever schema and table you have created in assignment 6, please go ahead and create the corresponding table in assignment. Right. So we can go ahead and create the tables, and we can start creating the tables. You don't have to create any table space because the table space is already created for you. When you create your table set and constraints, please make sure that you create all the parent tables first, the ones with the primary key and no foreign keys. And any table with the foreign key should be created after. What I'm going to do is, I'm going to forward you guys the graded Lab 6 by Thursday this week. So if there are any issues in it, they'll be in front of you to, consider fixing and then implementing. For the question number 2, give me till next time when I've covered database partitioning, and then since your lab is due on the 14th, you can probably implement the partitioning type, or maybe I can extend the lab by a few days so you guys have enough time to do justice to implementing assignment part 2 of assignment 7. This is all I have for today. If you have any questions, stick around. Otherwise, have a wonderful rest of the Tuesday, and I'll see you all next time, same place. Bye, everyone.